This question comes from Max, who asks, what if we built a Dyson Sphere around the sun?
Short answer, you'd have basically unlimited power, and one heck of an engineering, thermal, and ethical headache.
Let's start with what a Dyson sphere actually means. The classic image, a continuous solid shell enclosing the sun, is mostly a thought experiment.
Freeman Dyson originally suggested the idea as any structure or swarm that captures a star's energy. So when people say Dyson sphere, they often mean a swarm of collectors orbiting the sun and funneling its light to a civilization.
How much power are we talking about? The sun spits out roughly 3.8 times 10 to the 26th watts. For perspective, humanity's total power consumption today is about 10 to the 13th watts. A full Dyson scale capture would give you more power than civilization can imagine, enough to run trillions of Earths.
Where would you get the material? You wouldn't tear up the sun, you'd harvest the inner solar system. Think dismantling Mercury, smashing asteroids, stripping moons. That's a lot of mining. Dismantling a planet is beyond any current industry, but 1,000,000 years of industry might get you there.
Okay, we have materials. Now the obvious questions, can you build a rigid sphere? No. A solid shell at 1 AU would be gravitationally unstable. Any small perturbation and it would drift, collide with itself, and spaghetti the whole structure.
So engineers favor a Dyson Swarm, millions or billions of autonomous collectors orbiting the sun, each station keeping itself.
What happens to Earth while this is happening? If you partially shade the sun, even 10%, Earth's climate would start to change. Photosynthesis would drop. Crops would fail. Weather patterns would shift. Anything that blocks sunlight on a global scale is a global problem. A civilization that builds a Dyson swarm would need to coordinate on astronomical policy, and fast.
Thermodynamics sneaks in like a party pooper. You can capture sunlight, convert it to work, but ultimately, energy becomes heat. Heat has to go somewhere. If you funnel the sun's output into machines, those machines have to radiate the waste heat back into space. And radiation follows the Stefan-Boltzmann law. Hot things radiate a lot. Cool things radiate little.
If your collectors try to operate near Earth-like temperatures, you need enormous radiator area to dump that heat.
Numbers time. Quick and dirty. The area of a sphere at 1 AU. If your collectors reject heat at around 300 Kelvin, each square meter radiates only a few hundred watts.
To dump the sun's entire output at that temperature, you need more area than the 1 AU sphere, or you must operate hotter and radiate in the infrared. In short, where to put waste heat and how hot to run your hardware are central design problems.
The reaction of the sun? Practically zero. You haven't changed the sun's fusion. You're just intercepting the photons leaving it.
But if you captured most of the visible light, our star would look much dimmer from far away and very bright in the infrared. Astronomers searching for alien civilizations actually look for that infrared excess, a telltale sign of a very advanced energy collector. Then there's orbital dynamics. 1,000,000 collectors around the sun would interact gravitationally. Their orbits would need constant correction, autonomous propulsion, and collision avoidance. You'd essentially run a space city the size of the inner solar system with billions of moving parts.
What about stability close to the sun? Solar radiation pressure is huge. Satellites at different sizes feel different pushes from sunlight. Your swarm elements need active controls, sails, or tethers to stay where you want them. It's messy. Beautiful, but messy. Let's talk consequences for Earth if the Dyson project goes full tilt. If you privatize stellar power, you create astronomical inequity. If one nation or megacorp controls a star, Geopolitical dynamics shift to cosmic scale. And then there's the ecological part. Blocking sunlight ruins ecosystems. Any real builder would have to avoid catastrophic shading.
Could we do a partial Dyson? Yes. A ring of collectors at particular longitudes or power beaming stations that send microwaves back to Earth is more realistic.
Power beaming converts sunlight at orbit into tight microwave beams and sends them to receivers on Earth. But powerful beams come with safety concerns. Mispoint them, and you cook a continent.
The observational signature, a completed Dyson sphere, would make the sun dim in visible light and glow in mid-IR. We'd see that with infrared telescopes. If other civilizations built Dyson swarms, they could be detectable across the galaxy, which is why the idea shows up in SETI discussions.
And the weird philosophical effect, building one would be a marker of a civilization's ambition and risk tolerance. You go from using a planet to shepherding a star. You change your resources, your waste, your timescales.
Practicality checklist. Massive mining. Autonomous construction bots. Heat rejection infrastructure. Station keeping. Planetary climate management, and global cooperation or governance. Also, ethics. Do you have the right to alter sunlight for billions of organisms?
Finally, the human side. Imagine living under the glow of Dyson mirrors, your nights lit by redirected starlight, winters powered by stellar furnaces.
Imagine ceaseless industry in the asteroid belt, factory worlds churning into collectors. And imagine the first time we point an infrared telescope and see a distant star with the unmistakable heat signature of a civilization that learned to harness its sun.
So, what if we built a Dyson Sphere? You'd get near limitless power, a civilization upgrade to Kardashev Type 2, and a host of engineering and ethical headaches that make today's megaprojects look quaint. It's possible in principle, impossible with current tech, and terrifyingly consequential if anyone actually tries.
If you're excited by unlimited energy, pause and think. Do you want that power under careful global stewardship or in the hands of whoever can point the biggest collector? That's the real what if. If you're excited by unlimited energy, pause and think. Do you want that power under careful global stewardship or in the hands of whoever can point the biggest collector? That's the real what if.